like as usual, I'm going to show you the test. And I'm going to talk about the test, and I'm going to review for the test. Okay? I have to realize I have to be careful this year when I'm showing the test because I have the camera here. So if I show you the test, you can always watch it, zoom in, and get every question on the test if you like freeze it. But that's okay. I'll do that anyway. You know what I mean? It's not, the camera's right there. I'm going to show you the back of the test, and you're welcome to zoom in. This is the back of the test. Okay, you zoom in, you look whatever. Maybe you can read it backwards. You can read through that. Here's the front of the test. It's out of the camera. Now let's talk about each section on the test. I will read them off to you, though. All right? First, it's going to be a true and false section. It's going to be mostly on, you got to remember some of the stuff that's in this test you've probably forgotten about. Most of this stuff in the true and false in the first 6 multiple choice are going to come from the first couple of postulates and the quantum numbers. All right? They said that energy, or that electrons can only exist at certain energy levels. They could jump and quantum leap different energy levels. We did the flame test lab based on that. I have those to pass back to you right now. All right, I'll give those back to you at the end of the period. You want to read over those answers that I asked you on there because you didn't get full credit on those. And they're going to be, same kind of questions going to be on the test. All right, about the activity of electrons and the atomic spectrum. And you don't remember any of this stuff, I'll bet you, because it was like 2 weeks ago. So that's what you're going to be true and false questions based on that. There's going to be some multiple choice questions based on that and the quantum numbers and what they mean, like Pauli exclusion principle, Hund's rule, all that stuff in multiple choice and true and false format. Next section, 4 matching. Guess what they are? I told you about them the other day. Principal, orbital, magnetic, and spin. They're going to be on the left side. On the right side are going to be their definitions or something about them, and you just match them up. If you don't get that right, I have no sympathy for you. Final section is going to be like these. These are tough. They're the kind of questions you have to think about. They require you to synthesize some knowledge of the periodic table and electron dot notations and how many are in the outer shell, what energy level, all this stuff. Putting it together, trying to figure out what element we're talking about. Okay, there's going to be about 7 or 8 of those, I think. It looks like on here. And the final question on the front side is going to be a short answer question. And it's going to be very similar to the ones that were on the bottom of this lab. Okay? They asked you, those questions asked you about the activity of electrons when vaporizing the flame and what you saw when you looked through a spectroscope, the atomic spectrum. Both of those questions were answered poorly for the most part by most of you. Okay? You're going to have to do more detail on that. And if I have time at the end, I want to go through the main stuff. If I have time at the end, I will show you what I really wanted from that. But we'll see how much time I have. Hit that front light off for me now. All right. I can't help you with most of this front side. It requires you to study. Okay? But I can help you with, guess what's going on the back side? What's going to be on there? Bonus. No. Not the bonus. I mean, if there is a bonus, it'll be on the back. But what? What? What am I going to make you write out? What?
Like 1 through 4.
Like 1 through 4. Yeah. I haven't talked about. I didn't say they were on the front, right? You're going to write out those arrows, the orbital notations, the electron dot notations. You're going to also do these 2 math problems: the frequency wavelength ones and the energy wavelength ones. Right? That's what's going to go on the back. Okay. All right. Let's go over these. I can help you with this. This is about half the test, a little less than half the test is what's represented by these first 7 questions. Let's do them. You ready? Let's start off with this guy. Now, I put this at the bottom because you should write this at the top of your test, somewhere on the back. I would recommend writing this. That's the diagonal rule. It tells us the order in which they fill, right? Let's start off with nitrogen. And I'm going to save some time, I'm going to write nitrogen and I'm going to stop. I'll say, okay, that's nitrogen. Then I'm going to keep going through sodium and vanadium. Because after all, if I can do tin with 50 electrons, I can do everybody up to him. I just have to know when to stop. How many electrons are in nitrogen? How do I know how to write nitrogen? Well, let's take a look. Here's your periodic table. You find nitrogen on the periodic table. There he is. Let's zoom in. There he is, right there. How many electrons does he have? Everybody agree he has 7, right? So I got nitrogen with 7 electrons. Okay? I have to somehow fill up 7 electrons. What's the first thing that's going to fill? I look at the diagonal rule. What's the first thing that's going to fill up? Everybody agree it's the 1s? Yeah. We've been doing these for about a week, so we're probably getting good at it. 1s fills, I have 1 blank underneath every s I have, and I put 2 electrons in. After the 1s fills comes the 2s. and I fill him up. I put a little superscript above. This does not say 2s squared or 1s squared. It's 2s2, 1s2. After the 2s fills, what comes next? 2p or not 2p? How many blanks go underneath him? 1, 2, 3. And I fill him up. And that gives me a total of 10. I'm too far. I should have stopped. Where should I have stopped? How many did I need for nitrogen? I only needed 3 of them. And so let me just erase that because I'm going too far. I'm doing a larger guy. All I needed to do was this. 1, 2, 3, 1. And they go in one at a time before they come back and pair up. So that is nitrogen, correct? That's called Hund's rule. They go in one at a time. And so it should only have a 3 up here. Now, I don't want to have to erase and start all over again. Sodium has how many electrons? Well, look at your periodic table. Sodium is right here. So I zoom in on sodium. He has 11 electrons, right? Okay. Oh, and by the way, let's go back to nitrogen for a second. I didn't finish him because I had to do electron dot notation. How do I know what electron dot notation for nitrogen looks like? Well, if you look at him, he's basically in group what? 5, right? So he has 5 dots around him. There's 2 ways you could do that. You could look at nitrogen and say, okay, I look at the periodic table, he's in group 5, he's going to look like this. He's going to be N, 1, 2, 3, 4, 5. Or I could just look at what's his highest energy level. Highest energy level is 2. 2s and then p. He has 2 in the s, that's those 2 dots there. 1, 2, 3 or 1, 2, 3 here, right? That's how you do those when we first learned how to do them. Now, I'm starting sodium from scratch. I would do all of this exactly the same way, only I would complete this guy and give me a total of 6 there and 10 total up to that point, right? Sodium, you said, had how many? 11, right? I need 1 more electron. Where's he going to go? Well, I filled the 1s. I filled the 2s. I filled the 2p, and I filled, what's next? 3s. How many does he need?
1.
Only 1. This time I didn't go too far. And so that will be the end of sodium, wouldn't it? How would I write sodium's electron dot notation? Na, right? How many dots?
1.
Just 1. And again, I know that 2 different ways. I know it because his highest energy level is 3, and he only has 1 dot in it, and it's in the S. I also know it because here's sodium. He's in group 1. If he's in group 1, he has 1 dot. Everybody in group 1 has 1 dot. Everybody in group 2 has 2 dots, right? Okay. Now, I have to do vanadium next. What am I going to do for vanadium? Exactly what I did up to sodium, right? But then I continue. That gives me a total of 10 and 2 is 12. I need how many for vanadium? 23. 23 for vanadium I got to get to? So I got a ways to go. Who fills after the 3s fills? 3p, right? So 3p. 3 blanks underneath him. 6 electrons. That gives me 10, 18. I still need a few more. Where are they going to go after 3p? 4s. This tells you the order in which they fill, this diagonal rule. Maddie wasn't here for that, I don't think. She was absent. A couple other people. Bo was absent 3 days. All right. They have probably not used the diagonal rule, or certainly they haven't done the shorthand notation, which we just did yesterday. I'm going to show you how to do that next. All right. You simply follow this rule. After the 4s fills, what fills next? After 4s, 3d. How many blanks go underneath the 3d? Now, there's no getting around. You have to have some memorization. I try to do away with most memorization. I let you use the periodic table. I'm going to give you those numbers up there, Planck's constant, speed of light. There's a lot of things I'll give you, but there's something you can't get around. S has 1 blank, P has 3, D has 5, F has 7. Now, how many do I need to finish this guy up? I believe I only need 3, because up to this point I've got 20. Is that right? So with 20 up to there, I need 3 more. He should look like that. Now, I wanted to point this guy out to you for another reason. His electron dot notation for vanadium is kind of weird. You might think to yourself, okay, we've got 3 there. No, his highest energy level is all you include, which happens to be that. This is a lower number than that. 3 is smaller than 4. I don't include these 3 electrons. How many dots go to the right of vanadium? Just 2. As a matter of fact, how many dots go to the right of the guy after vanadium? 2. Yeah. Here's Here's vanadium, here's chromium, here's manganese, here's iron, here's everybody in the middle of this periodic table. Everybody in here. All right, from here to there. Oh, to there. Everybody there is going to have 2 dots. Really, that's not true. There's a couple of exceptions to that. However, for as far as you're concerned, that's true. All right, so let's finish this guy up. I did finish him up. V is it's got 2 dots. That's it. Now, I've got to do the shorthand one. I'm going to erase everything and clean it up a little bit here and start from scratch for the shorthand. The shorthand problem, all right, I have to worry about the nearest noble gas. That's what I'm looking for, nearest noble gas. So, oops, I think, yeah, there you go. Tin is right here. Right there. See him? Who is the nearest group 8 element? That's the noble gas. Again, Maddie wasn't here for that. Maybe some other people were absent for this. Here's tin. The nearest group 8 element that came before tin would be who? Everybody agree it's krypton? There's tin. It's krypton has 36. Tin has 50. I can't choose xenon because he's past him, okay? All right?
I have some questions on this. Like,
Hey,
I know you can't do it now, but like, are you gonna be
I'll be here.
school?
Yeah, I'll be your 8th period too, so you can then 8th period or after school, either way.
Okay.
All right. What was I going to say? Let's go back to my problem. All right, let's do tin. So I chose krypton for my nearest noble gas. Tin has a total of 50 electrons. That's a lot of electrons. I don't want to write out that many arrows. So I write down krypton. Is it krypton, right?
Yeah.
36? Is it 36? I can't read it.
Yeah.
36 electrons, right? Now, what comes next? That's the tough part. What comes next after that? Karen?
5s.
Yeah, how did she know 5s2 to be exact, is going to go next? Let me show you. If I look here at krypton, I know the last thing I would have filled up for krypton would have been 1, 2, 3, 4th row down. P block. I'm going to talk about that in a little bit too, where the SPD and 4th P block. Last thing I would have written was 4P6 for krypton. So the next guy to fill after that would have been, after the 4P, would have been the 5S. I know that by looking here, and I know that by looking at my diagonal rule. After the 4P fills, the 5S. And I can keep using that from then on. Watch. Once I know it's the 5S that fills next, I simply go from here. After the 5S comes the 4D. So I got a ways to go yet. I got 5 electrons, or 5 blanks to fill in there. Gives me 10 electrons. And that gives me a total of 36, 38, 48. I'm almost there. What comes after the 4D? Now, if you're still not sure, if you've been absent and you're not sure exactly why I chose krypton or how it got to be 5S next, it doesn't. I'll help you with that. But right now, it doesn't matter. Once you know you just filled up the 4D, what has to come next? 5P. You just go right back to the diagonal rule. Keep going from there. So 5P, 1, 2, 3. How many blanks? How many arrows do I need in the 5P? And they go in one at a time because of Hund's rule. And then I put a little superscript of 2 above him, and that is the shorthand notation for tin. Got it? Good. Hopefully you all got those right. That is a large portion of the test. There'll probably be about 5 or 6 of those in the test, maybe more. And each of them will have to have their electron dot notation. What would tin's electron dot notation look like? You can look, I erased it already. I could have looked at the highest energy level, or I could just look where tin is. What group is tin in? Group 4. First 2 go to the right, 3, 4. Everybody agree? Good. All right, let's go to the next ones. These are the problems. They're going to be on the test, probably 2 of them, maybe 3 on the test. I want you to show me the work like I've shown you for, since we did density problems. Okay? The problem with this test is I don't just have one equation. Last time we only had D equals M over V. Couldn't really get confused. I don't think you get too confused here, but here are your 2 equations. That one and this one. How do I know which one to use? Well, it depends on what the question gives me. This first question talks about wavelength. Well, that doesn't narrow it down because wavelength's here and he's here. But he also talks about energy. So energy and wavelength are in this equation. So I'm going to write delta E, H, C, and lambda. Now, the good news is I did not make you memorize these constants. What's delta E in the problem? Everybody agrees it's the unknown. Calculate the energy. We always see unknown. H is not going to be memorized. You're just going to be given it to on a test. 6.63 on 10 to the negative 34 joule seconds. C is given to you also. And wavelength is given in the problem as 2.58 times 10 to the negative 8 meters. Everybody good? Okay. Write the equation down. That's your first step. Next step, write the equation down. Delta E equals HC over lambda. Now, I don't have to rearrange this guy, but I might. On the other problem I asked you on the test. Might have to rearrange for wavelength, in which case you would do that algebraically. Multiply both sides by wavelength. Divide by delta E. Get him into the form where wavelength by himself in the numerator. This guy's set up right, so I just plug my numbers in. Delta E equals H times C over lambda and I'm all set to go. Now, you get your calculator out, you plug it in. You get this wrong on the calculator because of exponents or whatever, it's going to cost you a point. You get it wrong because of not showing me the work, it's going to cost you a lot more than a point. I do want to check the units here. That should not cost you anything. Seconds are here, they cancel. Meters are here, meters are there, they cancel. What am I left with? Joules. Okay? And if you did do the problem right, what did you get delta E to equal in this problem? 7.7 times 10 to the negative 18th. Anyone else get that? Okay, two things. Let's start with this one. First with the negative 18. Is that right?
Yeah.
Everybody else got that? Now, secondly, with the significant figure, 7.70. If it was like that, because significant figures, I got 3 there, I got 4 there, I got 3 there, I should have I should have 3 in my answer. Got it? Okay, good. Let's do the next one. It's a little bit shorter. This one's C. C, frequency, and wavelength. You know what it looks like. Okay. My C is, again, a given 2.998 times 10 to the 8 meters per second. What's my frequency in this problem? It's the question mark. It's the unknown. And whatever that thing is, the wavelength is 3.9 times 10 to the negative 6 centimeters. Now, be careful of this guy. This will happen on a test, too, almost guaranteed. You'll miss the centimeters here and meters there. I can't have that. You've got to convert one to the other. Let's convert the centimeters to meters. Centimeters go on the bottom. Meters on top. 1 meter contains 100 centimeters like we did 2 chapters ago. I got to make this guy 2 places smaller. How do I make a negative 6 2 places smaller? Negative what? So 3.9 times 10 to the negative 8 meters. Plug my numbers in, or no, write my equation down and check if it's set up. This one's not set up correctly. I need to solve for frequency, so what do I do to both sides? Divide by wavelength. You've got to get rid of wavelength, right? Okay, so frequency equals C over wavelength. So frequency equals 2.998 times 10 to the 8 meters per second over 3.9 times 10 to the negative 8 meters. And here's another mistake we're going to get. You ready? Meters will cancel and not leave you with seconds. Leave you with 1 over seconds, which are what? Hertz. What's the actual number, by the way?
7.7
times 10 to the 15th, is it? Is that correct? Somebody else get that? Okay. I'm not really worried about significant figures a whole lot, nor am I worried about calculators a whole lot, because the most you could lose in this test, I'm telling you right now, do nothing right. Don't even bring a calculator, and the most you could lose would be 3 points. 1 for this answer, 1 for the other answer, and then a half a point apiece for the significant figures. Okay? So you get a 97. Now, does that mean every test is going to be like that? No. Some tests you lose more because there's more math on it. This one doesn't have as much math. Does that mean you should never worry about or learn significant figures? No. But I'm just saying, people get all upset about significant figures and calculators when that's the least important part of the problem. Okay? All right. Last ones to talk about before, if I have a chance, I will, to talk about the lab report, those answers for those 2 questions. You're going to see questions just like that on a test. Take a look. These are the kind of questions I'm talking about that are tough. They have to require you to think. All right, if I look at this guy here, I want to know who's got 3 outer shell electrons and his highest energy level is 4. Well, I got to look at the periodic table. Let's look at the whole periodic table here. Okay? Oh, I forgot that. What was it? Say it for me again. What was the question? Do you remember?
3 outer shell electrons and highest energy level is 4.
3 outer shell electrons and the highest energy level is 4. Here's what that means. That means 3 outer shell electrons must be in group 3. Oh, all right. Must be in group 3. There's group 3. Everybody got it? So it's one of these guys. I've narrowed it down already. 3 outer shell electrons must be in group 3. It's either boron, aluminum, gallium, indium, thallium, or whatever. You're not going to see it. All right. The other piece of information it told me was that it's in the highest energy level is 4. Well, that means he's in row 4, or what we call period 4. Who is he? Gallium. Sure. He's got to be gallium. Okay? That's how you do those. Okay? That's how you do it. Let's see some other ones that are thinking questions like this. Ready? Oops. By the way, if you're wondering how I do some of this, I'm going to put that one back up in a second. The last orbital fill is the 3p4, right? That's where you kind of have to use this, which I showed to you a couple days ago. Okay? This is the S block. This is the D block. This is the P block, and this is the F block. What does that all mean? The periodic table is arranged the way it is for a reason. It makes life easier for us. I can tell you the last thing written on any element because all I got to do is know what row he's in. That's the highest energy level. What block he's in. And I don't have to memorize this, guys. I do not have to memorize this. How do I know this is the S block? How do I remember that without memorizing it? Because there's only 2 atoms in it. And we all know the S holds only 2 electrons in one blank. How do I know this guy's the D? There's 10. He has 5 blanks. D has 5 blanks, 2 electrons apiece, 10. P has 6, 3 blanks. F, 14, 7 blanks. So, let's go back to this question. The last orbital fill is 3p4. I'm going to be looking in the 3rd row. 1, 2, 3rd row. It's one of these guys. I'm going to be looking in the P block. It's one of these guys. And I'm going to look at the 4th guy in the P block. 1, 2, 3, 4. I don't know who that is, but I can look him up. And what is he? Sulfur. He is sulfur. Okay? All right. Now, how about this guy? He has that electron dot notation, and he's in period 3. Well, that tells me he is right here. He's in group 2. Remember, this is group 1, group 2, group 3, and so on. So I know he has 2 outer shell electrons. He's in period 3. He's got to be one of these guys. Who is he? Who is it that's in group 2 and period 3? Everybody see why he is not beryllium? You miscounted. Who is he?
Magnesium.
Magnesium, right. You see why he's magnesium? 3rd row, 2nd group. 2nd group is told to you by this. 3rd row is told to you by that. See it? Yeah. I'm almost done. It's my last question.
Okay, after that one.
Has 4 electrons in the 3D. 4 electrons in the 3D. You got to remember the one thing about the Ds is they always fill one behind. So this is 1, 2, 3, 4th row. That's where the 3D is filling. The guy who has 4 electrons in there will be the 1, 2, 3, 4th one over. What element is that? Everybody agree it's chromium? See on the periodic table, the real periodic table? All right, let me read this question for you because you're going to see a very similar type of question on the test from the lab, this lab that you guys did. Y'all read your answers? Okay. Describe the activity of electrons when vaporized in a flame. So what happens to the electrons when they get vaporized in a flame? You could tell me that the electrons get excited. They absorb energy. They quantum leap to higher energy levels. They can't stay there, so when they fall back down, they give off specific amounts of electromagnetic radiation, which we see sometimes as a color, okay, a wavelength of light. Okay? Go on. All right, so that would be a complete answer on the test. If you don't, write all of that on the test, you notice you were losing a point or two here and there. Let's read the second question. Okay, Becca, right? Or no? Yeah, you didn't. You weren't here for this lab, were you? Or were you?
Actually, I don't think I finished it.
Okay, well, I'm just saying that those two questions, if you can find it, are on this test as well. They're kind of on this test as well. All right, the second question, real quickly. We only have a minute left before the bell rings. What would be viewed through a spectroscope when observing a flame test or a spectrum tube? Okay, and what I would like you to have said there is you would view the atomic spectrum, which are then describe what the atomic spectrum is, which are the wavelengths of light. But you have to say the word atomic spectrum. Wavelengths of light that are given off when the electrons return to their ground state, their normal energy levels. And you should have also said they're as different as fingerprints. Every atom can be identified by that as well. Okay? So you needed to answer those like that. Most of you lost some points along the way. You didn't say the word atomic spectrum, or you didn't describe what the electrons did, quantum leaping to different energy levels. Okay? All right, expect to see that as a short answer question, one or both of those, or something, a variation on those on the test, guaranteed. All right. Do not have to memorize C or H, but you do have to know the equations, and you do have to know all the other